So I have the worksheet out. It says 2.5a on the top. If you were absent and didn't pick one of these up, I am going to link it in Schoology. So you will have to have that done when you come back on Monday. So if you didn't grab them from me, print one off from home. So I want you to look at the worksheet before we even start. Go take a look at it. And the goal is going to be to find dy dx. We're going to be taking a derivative. I'm just going to give you a new derivative process today. So go ahead and look at that. We're going to put stars by ones that you could take the derivative of without anything new, and that you should take the derivative of using an old method. All right, are you ready? Number 1 on the worksheet. You can't do that yet. So don't put anything by it. That's going to use today's process. It's called implicit. So can you guys put your phones away? Thank you. So number 1, you wouldn't know how to do that without today's method. Number 2, you could, but you're going to choose not to, so don't put a star by that one. You could actually take the square root of both sides and use some chain rule with a quotient rule embedded in it, and you would be successful, but today's way will be easier. Number 3, you can't do without today's process. Number 4, you can't do. Number 5, you can't do. Number 6, you totally could do. And you should do it without anything new. Put the phones away, please. I still see 2 of them out there. Thank you. All right. So number 6, what rule could you just use? Power. Yeah. You could just be done with it in one step. It's not even chain rule. So number 4, don't do today's. Number 7, same thing. You could write that as x to the 1/3. Just power rule it out. You'd be good to go. Number 8, same thing. What rule could I apply to number 8 that's not new? I would, and I would because it wouldn't be anything fancy in there. Number 9, 10, 11, 12 all need today's process. So you should have put a star by number 6, 7, and 8. Don't use today's process. Now, 13 you can cross off completely. We're not going to do that one. All right. So your goal by Monday is to do 1 through 12. What do you notice about the ones that I said you can't use it? Use old processes. Yeah, go ahead. Yeah, there's multiple variables on one side of the equation. That's your dead ringer for the fact that you need something different. So we're going to go to your notes. So open them to this page where it says implicit, and then can somebody tell me what page number it is, because mine aren't numbered. So open to the page that says implicit. Yep, page 68. If you are watching these at home, open up your notes to page 68. I'm also going to have you take out your calculators, because we're going to do this on a calculator first. We're actually going to do the same problem 3 ways on the calculator with the old process and with the new process, so you can see them all giving us the same answer. So here's the deal. We're going to consider the equation x squared plus y squared equals 25. You should recognize what that will make. So before we start, what does x squared plus y squared make if you were to graph it? It's a circle, yeah. So if you didn't recognize that, yeah, you ought to. But let's go put just a loose graph of that up here. It's a circle centered at the origin with a radius of 5. So go ahead and swing that around. Is it a function? Definitely not, right? It fails the vertical line test drastically. For every x, there's actually 2 y values, not one value that corresponds to it. It's not a function. It makes a circle. And the question becomes, can I still talk about the derivative on the graph at a certain point? So let's go to 3, 4, put a dot there. The derivative is the slope of the tangent line. This does have a tangent line, and that tangent line has a slope. So I can talk about the derivative of that function at any point, right? And even if the function were all wacky like this, at any point on it, I can, except right here because there's a cusp, right? I could make a tangent line, and that tangent line would have a slope. The question becomes, well, how do I get the slope there when the function's so messy? So I chose a pretty clean one to show you 3 ways. First thing we're going to do is go to the calculator. So down below, in order for you to graph that circle, you have to trick your calculator, because your calculator, go ahead and hit your mode button so you can see that there's actually other modes on your calculator that you've never gone to, and you won't yet. In Calc 2, we move over and use the other 3 modes, but what's the mode that your calculator is defaulting to? When you press mode, what does it say? Function. Yeah, you're in function mode, and you will be. But the other modes actually do allow you to graph some pretty weird things. They actually, if you go over to polar mode, we can graph flowers, and we can make all kinds of cool stuff. That's not till Calc 2. In Calc 1, you're in function mode all the time, so you kind of have to trick it into graphing this circle. But in polar mode, I can have it actually go. Let's give it a whirl. Hit the polar. Go over to polar on your calculator, and I'm not going to bring mine up, it's not worth it. And now go hit y equals, and it won't say y equals. What does it say? R equals. Well, it's asking you for the radius of your polar function, which is just 5. So if you hit a 5 and hit graph, it'll actually graph that circle in one full function. You know what I mean? So go ahead and give it a whirl. You should see it graphing the circle. Now get out of polar mode. Go back to mode, go back to function, never move it again until you're in Calc 2. But when I'm in function mode, I've got to solve the equation for y. What if you can't? That's what we're going to talk about next. So in order for me to solve, let's write the whole thing. X squared plus y squared equals 25 for y. Let's go do that quickly. I'm going to subtract the x squared. It's super easy. I'm going to take the square root, knowing that I'm going to need the plus or minus. So I'll let you guys go ahead and just work that out. So if I want in function mode for my calculator to graph that circle, I have to enter it as two separate functions. The top half of the circle, which is indeed a function, and the bottom half, which is indeed the function, correct? And then your circle will make two semicircles pieced together. We're only going to be talking about at the point 3, 4. So we don't really only need the top half of the circle. So if you could, go to your graphing calculator in function mode and enter the function y equals the square root of 25 minus x squared. And your calculator will graph the top part of the circle. And we're going to tell the calculator to find the slope of this tangent line. So we're going to do it on the calculator first. So can I keep going? We got it graphed? All right, so you're sitting there staring at the top half of the circle. If your calculator has a graph, it will do the derivative at any point you tell it to. If you hit second trace where it says calc, so go ahead, hit second. And if you're watching these at home, you should make sure you pause the video, go get a calculator. Hit second trace, which is actually going to be your calc option, and go look at the options on there. What one do you think we're going to choose? Just dy dx. Yep. So you're going to choose dy dx. What number is it? Is it 6? Yeah, so go choose dy dx. Your calculator will just ask you to enter the x coordinate of the point. So we're going to find the slope of this line at 3, 4. So if you could hit 3 and then enter, your calculator will calculate the slope of the line at 3. It won't draw the line, but it'll tell you on the bottom left. Go ahead and hit 3 and then enter. And it tells you dy dx equals, and what does it say? Negative 0.75. All right, if you didn't get that to work, no big deal. We're not going to do them on our calculator anyway. I just want you to see what we're going to get when we do it analytically or with some algebra. So next page. How could we get that negative 3/4 algebraically? We actually don't need a new method for that one. Because I had it solved for y, let's go write it. It was 25 minus x squared, and we're dealing with the positive root because I'm focusing up at 3, 4. Let's write that to the 1/2 power, and let's do that with a method we already know. What rule can I apply to get the derivative of this function right now? This is chain rule and a nice two-stepper. So for me to figure out the derivative, I'm going to do 1/2 of 25 minus x squared. I'm going to knock the power down 1. And then what am I going to remember? The guts. Thank you. Multiply by the derivative of the inside function, which would be negative 2x. Nothing new here yet. And I'm going to go clean this up, get rid of my 2's, throw my negative exponent down in the denominator. So it looks like I'll have a negative x over the square root of 25 minus x squared. That is my derivative. We want to find the derivative at, and here's some am going to start using this notation a little bit more. Instead of writing f prime of 3 or y prime at 3, I'm going to find the derivative at the point 3 comma 4. Note that my expression for the derivative only requires me to put an x value in. We say it's explicitly in terms of x. Y was solved as a function of x. My derivative is a function of x. When we do it implicitly, you're going to need both x and y to go in. But this one, I could just say, okay, it's going to be negative 3, the opposite of the x value, and square root of 25 minus 3 squared, which is 9. And notice I get that negative 3/4 that your calculator gave you. It gave you the negative 0.75. This is called explicit. Not really important that you know that, but I was able to write y explicitly in terms of x. My derivative came out in terms of x, and I just had to plug an x in. Here's the problem with this method and only knowing that. What if I couldn't easily solve it for y? This was fine because I gave you a nice simple circle. But what if the function was this thing and its equation was like really wacky, like x squared y plus sine xy times e to the xy? You want to try to solve that for y? Usually you actually can't. Sometimes you can, but even if it's a simple one, like look at your worksheet. Number 2, could I easily solve that for y? What do you think? Yes, don't. Implicit will be easier for that one. All right, so although you even sometimes can, I would from here on out maybe choose not to. Unless it says y equals, I would launch into the implicit process. So it says, what if we had an equation which could not be solved for y easily, if at all? So let's put one that's really ugly. Xy squared plus sine of xy equals tangent y. I have no clue what the graph of that makes. If I had a TI-89 calculator, do any of you have one? No. I want to get a couple, but then that'll actually graph non-functions, but I have no clue. And to solve this for y is probably impossible. So I need another process because it does have a graph. The graph just probably isn't a function, but it's still, I'm making a fake graph. It still has tangent lines and they still have slopes. So here we go. How would we do it? We're going to have a series of steps. The process is called implicit differentiation. It's not difficult, by the way. It's going to be one of the things you find easier in this class once we get past today. The first day is a little rocky. By day 2, you'll be pretty good. By day 3, you'll be great. Usually I don't have anyone who has an issue with implicit after doing it for a while. Implicit differentiation. All right. You use it when x and y are. I think, Freedom, you already said that. Like when I said those ones on your worksheet, like number 1, he said, I don't remember how you phrased it, but it was good. There's multiple variables on one side, but let's just say when x and y are on the same side. Not always the case, but usually that's what happens. Let's go try the circle, method 3. Method number 1, I did it on my calculator. My calculator said the slope of the tangent line was negative 0.75. Then I wrote the derivative as a function of x, and I plugged in the 3, and I got negative 3/4. I'm now going to launch into process number 3, which I would for this one. It's a little easier. It's called implicit differentiation, and I've got multiple variables on one side of the equation. Here's how it starts, and then we'll write the steps up on the next page. You do what you almost always do when you're solving an equation. You do something to both sides. When you first started pre-algebra, you'd like add 3 to both sides. Well, I'm going to take the derivative of both sides of this equation. So let's go take the derivative of the left and set it equal to the derivative of the right. And I'm doing a simple, oops, sorry, that was a 25. Your variable of change is x, and that's what we'll keep it for now. We'll eventually mess with that. By the way, in the real world problems, which are coming eventually in about a week, what is it? It's usually not x that's changing. What is it that's changing in the real world? Time. That'll become a dt, actually. And the problems get really good. So let's go take the derivative of the left, and I'll show you where you have to be careful. What is the derivative of x squared? 2x. That's easy. However, the derivative of y squared is not 2y. I have to show you over here. I'm going to go put a little box. Don't write this in your notes. I just want you to watch it so you can see why we do what we do. So what do we also call y in this class? Sometimes we call y f of x. It's a function of x, right? So let's pretend it was the derivative with respect to x of y squared. You would do 2 times that function to the first power times the derivative of the guts, correct? So we would write it as f prime of x. So what happens when we replace that with a y? Let's go do that. When I do d with respect to x of y squared, I do 2y, but I multiply it by the derivative of the guts. And what is the derivative of y called? Y prime. So when there's not a variable match here, I go ahead and I take the derivative of y squared and call it 2y, but y is itself a function, so I have to chain rule it out. It's actually going to be 2y times dy dx, or y prime. It's easier algebraically to work with it as y prime than dy dx, so go ahead and call it y prime. On the right-hand side, what's the derivative of any constant? 0. Yeah, this is the function y equals 25. It's a horizontal line. Doesn't matter what x is, the derivative everywhere on that horizontal line is 0. So remember, I'm trying to figure out what y prime is. I'm trying to figure out the slope of the tangent line. So now I'm going to isolate it by subtracting 2x. I'm just going to do algebra manipulation here. I'm going to divide both sides by 2y. Let's just go like that and go like that. I'm going to cancel the 2's, and my y prime is going to be negative x over y. Notice now my y prime involves both an x and a y, not just in terms of x. But watch when I find the derivative. Remember, this was a circle. I'm trying to find its derivative at the point 3, 4. The derivative at 3, 4 is going to be negative the x coordinate over the y coordinate. Same answer a third way. So we did it on the calculator. It said negative 0.75. We did it explicitly by solving it for y, and we got it as a function of x, and we plugged the 3 in, but we got negative 3/4. And now we have a third process called implicit, which requires me to plug in both x and y. Actually, in Calc 2 today, I was making a key, and there was one. I'm just going to show you. They were actually finding the perimeter of a hypocycloid, which you don't need to know how to do, but a hypocycloid, it looked like this. And they were trying to figure out the perimeter of it, and they have a formula that's for arc length that helps them find the length of a curve, which is kind of cool because you guys don't know how to do that yet. But it involves taking a derivative, and this function is actually x to the 2/3 plus y to the 2/3 equals 1. If you were to graph this, it makes what's called a hypocycloid. And they were to find the perimeter of it, and we had to take the derivative. Do you think we chose to do it explicitly and solve it for y, or do you think we're going to choose to do it implicitly? Implicitly, because explicitly I've got to subtract x to the 2/3, I've got to raise it to the 3/2 power, then I've got to chain rule it with negative fractions, and it gets really messy. So implicit is what we go to a lot, and most of the stuff we deal with in real life problems, they're not functions, and they're curvy. You know what I mean? Like they're weird. Like if this were the surface of a lake and I wanted to figure out its surface area and or its volume, that isn't made up of just nice lines, and it's all curvy. And so we usually choose to go implicit when it works better. So let's write those steps down. First of all, I took the derivative of both sides. So let's write take derivative of both sides. You don't need to move anything around. Just take the derivative of both sides to start the process. And that's what I did on that circle. Then I tried to get y prime by itself. And the first step in getting y prime by itself is to get y prime on one side of the equation. Technically, the left is easier. So you're going to get all terms involving a y prime all on one side. You're going to get all the non-y prime terms over to the other side. Then you're going to factor y prime out. It's very algorithmic, so you won't even need to look at these steps because after you do one of them, you're going to just, oh, yeah. So you're going to factor y prime out, and then you're going to divide. And we're going to run through that whole 4-step process with a nice easy one. Then I'm going to bump up the difficulty, and then I send you off to work pretty soon. So mainly just practicing these makes you good at it. You don't need to see me doing a zillion of them. Let's go start this. First of all, this is definitely a candidate for implicit. I've got multiple variables on, and when you get to a multivariable calculus, which is Calc 3, guess what the third variable is? The x-axis, the y-axis, and the z-axis, which gives your graph depth as well as just 3 to the right, 4 over. You also go up 5 and you're in 3 space. But for us, we've got 2 variables, one side of the equation, dead ringer for implicit. It starts by taking the derivative of both sides. And so we'd have the derivative of the left. You'll eventually stop writing this first step, but not today. Today I want to see you taking the derivative of the left-hand side and setting it equal to the derivative of the right-hand side. If the thing you're taking the derivative of involves y is a function, you will be doing some chain rule. If it only involves x, the derivative is what you would think it would be. So let's start here. The derivative of 3y squared, of y cubed would be 3y squared times the derivative of the guts, which is a y. What's the derivative of y? Y prime. You could write dy dx, but the algebra is smoother if you call it a y prime. Then I'm going to do the derivative of a function squared. I do 2 times the function times the derivative of the function, which is y prime. Then I'm going to do the derivative of minus 5y, which would be minus 5 times the derivative of the guts, which would be y prime. And then I'm going to do the derivative of x squared, which is what? 2x. The guts of that is x, and the derivative of x is 1. See how it works out nicely? On the right-hand side, what's the derivative of my constant? 0. So then my goal is to solve for y prime. I'm going to isolate it by moving all non-y prime terms over to the other side. So really, let's just cross this off. We better not. We better rewrite. Otherwise, you're going to not be able to follow your notes. So I'm going to keep all y prime terms on the left. Had there been some of them over on the right, I'd move those over to the left as well. I'm going to put my non-y prime term on the right-hand side. That allows me to isolate it by factoring it out of every single term here. So I've got y prime times 3y squared. Just pull it out of the middle term, pull it out of the last term, equals 2x. And my goal is to figure out what's y prime. I have it. As long as I divide both sides by that big chunk of stuff, which I don't feel like rewriting again. So let's just cross it off and we'll divide. Your last step is always to divide. This is my derivative. Notice it's a function, it's actually not a, I should say it's a relationship that involves both x and y, not just x. You're used to getting f prime of x equals and everything's in terms of x. When you do it implicitly, the derivative depends on both x and y. So let's go ahead and call that dy dx equals. And let's go answer a couple other questions about it. So it says, where's the slope of the tangent line undefined? In order for a derivative, aka slope of a tangent line, to be undefined, what has to occur? Yes, sort of a vertical line, yes, would occur graphically. So what he's saying is, so were I to be able to know what the graph of that looks like, but I don't, I would be dealing with this situation where the tangent line is vertical. That's actually what you're looking for graphically. Algebraically, though, what has to happen for this fraction to be undefined? The denominator, exactly, has to be 0. Let's go do that. You're on fire today. All right. So we set the denominator equal to 0. And in this class, whenever you're looking for where something equals 0, if it's non-calculator active, it will factor and it'll factor nicely. If you have a calculator, you'll graph it in Calc 0, but we're primarily no calculator first semester, so it will factor and it'll factor slick. It won't be like you're trying to factor it for 5 minutes. It'll be nice and easy, Algebra 1 factoring. So what do we need here? A +5, a -1. You might want to double check your outside and inside, but that one's good. So this has two places, maybe, I mean, we'll see, where the slope of the tangent line is undefined. At y equals 1 and at y equals -5/3. And just to avoid spending a bunch of time on arithmetic, I'm actually not going to go plug these in. But in order for you to figure out these x coordinates, what would you plug the y's into? What do you think? What would I plug y into to figure out the x values? The original function. Yeah, it's points on the curve. If you plug them into the derivative, they're going to give you 0. That's what we just figured out. So I'm going to leave that undone just because I don't want to waste your work time doing arithmetic. But we've had this question before too. It says find the equation of the tangent line. Circle that. And your brain should say I need two things. The two things are a point, which they handed me. So at 1, -3 on that curve. And again, I'm making a fake curve, but somewhere there's a 1, -3, and you are going to give me the equation of the tangent line. So you also need its slope. The slope is the derivative. So I need dy dx at, I like this notation, I'm going to start introducing it more and more. You've been used to doing f prime of x, but now it's dependent on both coordinates. So in order for you to figure that out, you would go plug these coordinates into, go draw an arrow because I'm going to skip the arithmetic just to give you some more work time. You'd plug it into your derivative formula. Maybe if someone wanted to do that, you could do it for me while I'm talking. Who's quick at arithmetic? You got it already? Thank you. What is it? 1/8. Awesome. Thank you. So then you can go ahead and write your equation. Y minus the -3 is equal to the slope there times x minus 1. And you just leave it. And we're done. So last one up of these, and then we'll do an AP problem. And I want you to put a little, be careful, and I want you to point right here. I'll tell you why to be careful. I said this last hour too. I said you gotta be careful with this kind. And the first one on the homework is this kind, and 3 people didn't do what I said to be careful about. So I want you to write be careful. And then I'll put y once I start doing it. So my derivative is going to be determined by both x and y. It's going to be an implicit process. You can see x and y living on the same side of that equation. Trying to solve that for y would be a mess. So I'm just going to start. What's the first thing I said to do? I'm going to launch right in. Take the derivative of both sides. Yep, with my variable change being x. So I'm going to do the derivative of the left with respect to x. And I'm going to do the derivative of the right with respect to x, doing the same thing to both sides of an equation, which we've been doing for years. Now, every term that has a y in it is going to have some guts, and it's going to need some chain rule. This, the derivative of x cubed, is 3x squared, and the derivative of x is just 1. So, it just is going to be 3x squared. But be careful, and I'm going to write this with some formal notation. I need to do the derivative of 6xy. I'm going to wait and do that in a little bit, because that's the thing that I want you to be careful about. The derivative of y cubed, true or false? 3y squared. Whoopsie. 3y squared. False, because y is itself a function. So I do 3y squared times y prime. That one was easy. The constant on the right, its derivative is 0. This is what I need you to be careful about. It is not 6x y prime. It's a product, and it needs the product rule. So write be careful, go point right there, and write product rule. And you will forget it for a while. College Board loves to throw that one on there where that you have to use product rule. So we're going to be really careful. Product rule says, so let's go start this over again. Product rule says that you do first, let's call it 6x. D second Well, that's just dy dx, or the derivative of y, or y prime. That's first d second. You also need to do second d first. What's d first? That's what most kids forget, is to do this. They just go 6xy prime because they memorize in their head that every time there's a y term, they tack on a y prime. But keep in mind, all other rules apply. So product rule, first d second plus second d first. And then I have this. All right, next up, what would I need to do? Isolate y prime. So I'm going to get all non-y prime terms over onto the right-hand side. So I'm going to keep my 6xy prime. I'm going to keep my 3y squared y prime, because I want to figure out what y prime is. I'm going to move over my 3x squared and my 6y. Why do I do that? What's the next step? You shouldn't even need to look. Yeah, I did it so I could factor that y prime out. Let's go do that. I'm going to write y prime times, take it out of the first term, leaving a 6x. Second term, leaving a 3y squared. And it's going to equal all of this. What's my last step in the isolation process? Yeah, exactly. Divide both sides. Let's just cross it off for time purposes and go like this. Now, if this were a free response question and it just said find the derivative, you could be done. If it's a multiple choice question, it might look a little better, because what could you do with it? What could I factor out of the top? A 3. What can I factor out of the bottom? A 3. They are going to cancel and I'll get a simpler form. So I'm just going to write, you might need to factor that. Actually, for this one, because I did ask for you to do it at a specific point, if you didn't have a calculator, it'd be way easier if you pulled the 3 out and canceled it. I'm not going to go do the arithmetic of that, though. Let's just leave it right there and be done with it. But you should factor that. Last up, I took this from the 2008 actual test. They used to release the tests every 5 years. The last one they did that for is 2008, though. So I have the actual tests of 1998, 2003, 2008, and then they quit doing it. But on the 2008 test, this had only a 13% success rate. It was incredibly low. And I'm going to show you the step in here where kids, I think, goofed up. I don't know, but that's my guess. I didn't teach this in 2008, so I can't tell you what my kids did. You know what I mean? I can just say that the stats were horrible. We're going to start. I want you to go like this. Let's rewrite this. The goal is to find dy dx. I'm sure almost every kid launched into implicit because they saw x and y on the same side. They knew it'd be a pain in the butt to try to solve it for y. They'd need to do arcsine and all kinds of, you know what I mean? It wouldn't be pretty. So we'd launch into implicit. So I'm sure this first step wasn't the reason the stats were so bad on it. Let's go do that. That I don't think was the problem. I don't think the next step was the problem either. Let's go take a look over here. First of all, what is the derivative of sine? Cosine. I'm sure that was pretty well known by most kids taking the AP test, that this is going to be cosine of that stuff, right? But you're not done, right? Let's go back over to what you know. If I asked what's the derivative of sine 5x, what did you say it was? Cosine 5x times 5. So this is cosine xy times, and I'm going to use the formal notation, the derivative of xy, which is not y prime, and it's not xy prime. So we're going to be really careful with that, which is why I'm going to do it as its own separate thing. The derivative of x, though, is just 1, so I don't think that was an issue. I think that some kids failed on this one, and then they got one of these answers over here. It's going to be one of those. Some kids just didn't do what rule on xy. Product. Awesome. You guys are awesome. I need to take cosine of xy and then do the derivative of the guts, which is itself a big expression. I have to do, you might want to point at that and write product rule. I have to do first x, d second. What do we call the derivative of y? Or dy, yeah, y prime. You're not done though. If that's what all you did, your answer would have been this wrong answer right there that I circled. if that's what you did. All your wrong moves are one of those answers. This is first d second plus second, and what's the derivative of x? 1. There. And I think that some kids got past that hurdle. About half would be my guess. Just having done this for a long time and having tested people on this, about half handle that hurdle just fine. I think actually this is where there was an issue, knowing what to do right here. So I'm going to go back to the first time you guys learned how to solve equations, and the variable you were trying to solve for was stuck inside of some parentheses. What did your junior high teacher tell you to do with that 2? You could divide it. I wouldn't in this situation, especially if it leads fractions, it gets kind of ugly, but you could, right? But what else did they say? Hippity hoppity, distributive property, right? They'd say, hop that on in and get that x out of the parentheses. And that is its equivalent here on steroids. Your y prime is locked in a set of beefies. You need to get it out. So you need to hop this in and get it out of there. And you have to be careful how you write it. I wouldn't write cosine xy and then xy prime, because it looks like you're taking the cosine of the whole thing. I would put that part of the product in front. Then you're going to do plus cosine xy times y. But again, I'd throw that out front so it's not unclear what you're taking the cosine of. So all I did was the 7th grade version of the distributive property. That equals 1. What am I trying to solve for? Don't lose track of that. Y prime. I need to keep all terms, this is an entire term involving y prime on the left. I need to move over all non-y prime terms. So I'm going to, and this is the first day of it, so I'm talking a lot. We're going to do this Monday and Tuesday, and I'm only going to talk for about the first 5-10 minutes, and I'm going to let you practice implicit. The more you practice this skill, the better you get. So really what I've got here is a bunch of stuff in a product involving y prime. So I'm just going to divide off everything else. Can I just do it right on the, I don't want to rewrite it. Let's go divide both sides by x. Let's divide both sides by cosine xy. And that's as good as it gets. Which I lost my options. What letter would that answer have been? That's D. Only 13% of all kids taking the AP exam that year correctly answered D. Do you see where their mistakes might have been? That product rule, the distributing. We're done. So your assignment is to do 1 through 12 on that worksheet. You're going to do it on a separate sheet of paper. I for sure want you to get number 1 done at least before you, I know it's Friday, you probably don't feel like working a whole lot, but I want to make sure you can do one of them. I will post the full worked out key as well. Day 1, I post the full worked out key. Day 2, we do this. I'll just give you the answers. And day 3, I'll probably yank all support material and have you just do it on your own. 1 through 12, I should be able to post those answers, like the worked out solutions. The bottom of your worksheet has the solutions, but I'm going to work it out so you can see it. That's not a very labor intensive assignment. It takes 15 to 20 minutes maybe. But what would I like you to putz at over your 4-day break? You have that big packet out there that has a due date now of next Thursday. If you wait till Wednesday night, that's going to be a lot of work for you. So just know, it's not like we're doing other stuff next week as well. So I would start putzing at that big packet. We're done. Go ahead and make sure you can do number 1. If you can't get the answer on that sheet, let me know.